Hi guys, I would like to take us through percent purity experiment. In chemistry, percent purity experiments determine the proportion of a desired substance within a sample. This is usually achieved by dividing the mass of the pure substance by the total mass of the impure sample and multiplying it by 100. So going through this Evirtuallab, you can also do the same experiment yourself on evirtuallab.com. So this is how the apps looks like. You have several experiments on your left hand side. So for this experiment, we want to do percent purity. Then we click percent purity. And once you've done that, it shows us the apparatus on the right, on the left hand side, and at the bottom of the laboratory. So the next thing is for you to enter the lab by clicking enter laboratory. After that, you run experiment. Once you click run experiment, it brings you to the lab environment. This white table is your lab environment, and you have instructions on how to use the experiment. You have instructions. Number 1, it says click on the apparatus from the apparatus bar located on the right, left, and bottom of the screen. Then you click the lab table to animate the next step, which means we don't drag. Once we click the apparatus, then you click the lab table. So you also have, for the first time user, we have instructions at the bottom of the lab table so that you know the steps to follow. So these are the steps to follow for this experiment. You can write it down, or you go to the website of the Evirtuallab. The manual is also there. You can go there and get the steps to follow. And some values have been given on the lab table, which students must write down for calculation. Here it shows that the pipette volume is 25 cm cube. The burette polarity is 12.41 gram per 500 cm cube. Impure salt weight is given as 4.4 gram. Salt volume is given as 250 cm cube. And you have the stoichiometric ratio of hydrochloric acid to sodium hydroxide. So for us to start the experiment according to the instructions, I have the manual with me, so I won't be going back and forth. The first thing is to pick the weighing balance. So we pick the weighing balance here by clicking it. Then, according to instruction, you click this lab table. So you click the lab table to bring the weighing balance to the lab table. The next step is to pick the Petri dish. You do that by clicking the Petri dish. Then you click the lab table to place it on the weighing balance. The third step is to click the salt, pour some quantity of it into the Petri dish. The next step is, once that is done, see, based on what is given to us from on the lab, it says the impure salt is weigh 4.4 gram, and we can see it on the readings that it is 4.4 gram. So the next step is to pick the beaker, then click the lab table to bring the beaker to the lab table. Now we have some salt in the Petri dish. So it's showing here that it's Petri dish salt. Unlike before, it was just Petri dish. So now we click the Petri dish salt, click the lab table to pour it into the beaker. In order to dissolve the salt, we pick water by clicking the water bottle and click the lab table. Some volume of water will be poured into the salt to dissolve it. The next step now is to pick the round bottom flask in order to make up the solution that is required. You click the round bottom flask, click the lab table, comes there. Then we click funnel. I have to insert funnels into the round bottom flask so that the solution does not split. So we click funnel and click the lab environment, which will be inserted into the round bottom flask. Then now we have some solution in the beaker. So it's not just beaker. Here it's telling us that it's beaker filled because of the solution we have in it. So now we click the beaker filled, then click the lab table to pour it into the round bottom flask. Correct volume. Okay. So in order to make up the solution, we click the water bottle again and click the lab table so that we can make up the solution of the round bottom flask. So the funnel has been removed itself. The next stage is to click the cork so that we can cork it and shake it for it to mix. So to do that, we click shake round bottom flask. Then we click the round environment again to do that. So to start preparing for the titration, we click the burette, which will be mounted on the lab table. Then we have to insert the funnel onto the burette. We click funnel and click the lab table for that to be done. Then the next stage is to pick the acid, which will be done by clicking the acid and click the lab table. And the volume of the acid will be poured into the burette. So to continue with the titration experiment, we have to remove the funnel. We pick the funnel by clicking it and click the lab environment for the funnel to be removed. So the next stage is to click the pipette to the lab table. You click the lab table to draw the solution from the round bottom flask and pour it into the conical flask. So that we go into the conical flask as seen. The next step is to add pH indicator, some drops into the content in the conical flask. So we pick pH by clicking it, indicator, then we click the lab table to add some drop of pH indicator into the content. So it's shaking itself. So we can observe the color change. So we pick the titration to start our titration. We pick titration to the lab environment by clicking it to start the titration. So once that is done, it won't start until we start the button. We click the button to start the titration experiment. So we click the start button and we observe the process for color change. Once the color changes, we click stop. We observe color change to pink. So once it changes, we click stop. So we have the first titer value to be 15.37. Any student going through this experiment is expected to write down the titer value for all the runs. So for this, we have 15.37. And you are expected to do 3 runs. So we close it. Then we click run 2 to do the second run. So we don't need to start the experiment all over from the beginning. All we just need to do is to click the start button and wait for color change. Then you click stop button. So we still have the same value, 15.37 for the second titer value. So we close it for the third run. We click start button to start the third run and wait for color change. Then we'll stop it. So the third one, we'll see the titer value by clicking show results. So the student will click show results. For the third one, as a student, I didn't stop the experiment on time. So the third one, I have 15.67. 15.67. So here, the student is expected to calculate the average titer value by adding these 3 titer value and taking the average, dividing it by 3. So we have 15.47. So the student is expected to get the pipette molarity. So our VB here is 0.42. That's pipette molarity. And the percent purity is calculated to be 95.45. So any student that wants to try this experiment is expected to go to evirtuallab.com. All the formulas required to do all the calculations are in the manual, and the manual is inserted in the website. So once the student is done calculating all this, the student will submit the calculated result, and the student is expected to print report for his or her teacher. So once you click print report, you see this environment that compares the actual that is expected with the experiment the student did and calculated, and the system. Let's say the student failed to calculate the experiment and just submit the blank page. This system will also help the student to do the calculation. So this is the student computed result. The system did this for the student. So to compare these 3 results for what is actually expected of the student, the titer value is 15.368. And because of the delay in stopping the third run, our titer value cannot be the same. So here, the titer value is 15.470. And the alkaline molarity here is calculated to be 0.418. That's what is expected of us. But because the average titer value was used in the equation used for calculating the alkaline molarity, we have 0.421 because of the delay we have in the third experiment. Hence, we could not get the same value, but it's actually close. Then the percent purity is given as 95%. That delay also affected our percent purity. Here we have 96%. And if we compare it with what the system helped the student to calculate, in fact, the system used what is expected to do the student computed result, not what the student did as experiment, because what we have here is close, very close to the actual. So the percent error, when we compare it, we have 1% error because of the slight delay in stopping the experiment when we compare it to the actual. So the student computed one is 0% error, the one the system calculated. Then the pipette molarity, we have 1% error, and the percent purity is also 1% error. Thank you for listening.